Exoplanets are worlds that orbit stars beyond our sun, planets scattered across the galaxy in numbers so vast that they redefine what we thought the universe contained. For most of human history, the idea of other worlds was pure speculation. The night sky appeared as a distant ceiling of lights, unreachable and mysterious. Our solar system was once believed to be unique, a rare arrangement of planets circling a single star. But in the last few decades, astronomy has revealed something extraordinary. Planets are everywhere. The Milky Way alone may contain hundreds of billions of exoplanets, meaning that there may be more worlds than stars. Some are massive gas giants larger than Jupiter, orbiting so close to their stars that their atmospheres boil under extreme heat. Others are rocky planets, similar in size to Earth, hidden in the habitable zones of distant suns where liquid water might exist. The discovery of exoplanets has transformed our understanding of the cosmos because it suggests that planetary systems are not unusual accidents, but natural outcomes of star formation. Every time a star is born, a disk of gas and dust forms around it, and within that disk, planets can emerge. Exoplanets were once invisible to us, too faint and too distant to see directly, but scientists developed ingenious methods to detect them. One of the most successful techniques is the transit method. When a planet passes in front of its star, it blocks a tiny fraction of starlight, causing a subtle dip in brightness. By measuring these dips repeatedly, astronomers can determine the planet's size, its orbital period, and even clues about its atmosphere. Another method is the radial velocity technique, which detects the slight wobble of a star caused by the gravitational pull of an orbiting planet. Even though the planet cannot be seen, its presence is revealed through the motion of the star itself. There are also other methods, such as gravitational microlensing, where a planet's gravity briefly magnifies the light of a background star, or direct imaging, where astronomers capture rare photographs of young giant planets glowing in infrared light. These techniques together have uncovered an astonishing diversity of worlds. There are hot Jupiters, gas giants orbiting so close to their stars that their years last only a few days. There are super-Earths, rocky planets larger than Earth, but smaller than Neptune, a type of planet that does not exist in our own solar system. There are many Neptunes with thick atmospheres of hydrogen and helium, and there are planets locked so tightly to their stars that one side is eternally scorched in daylight, while the other remains frozen in darkness. There are ocean worlds that may be covered entirely in water, and lava worlds where the surface may be molten rock under extreme heat. Some planets orbit not one star but two, like the fictional planet Tatooine, where sunsets would appear double. There are even rogue planets, worlds drifting through interstellar space without any star at all, wandering in darkness, warmed only by internal heat. The study of exoplanets is not only about cataloging strange new worlds. It is deeply connected to one of humanity's oldest questions. Are we alone? If planets are common, then the conditions for life may also be common. Astronomers now search for planets in the habitable zone, the region around a star where temperatures might allow liquid water to exist. But habitability is more complex than distance alone. A planet's atmosphere, magnetic field, geology, and history all shape whether life could arise. A world too close to its star may lose its water through runaway greenhouse effects, while a world too far may freeze into a permanent ice age. Some stars, such as red dwarfs, are extremely common, and many rocky planets have been found orbiting them. But red dwarfs can also produce powerful flares that may strip atmospheres away. The question of life depends on countless factors, making each exoplanet a unique experiment in cosmic possibility. The next frontier is the study of exoplanet atmospheres. When a planet transits its star, some starlight passes through the planet's atmosphere, carrying chemical signatures. Telescopes like the James Webb Space Telescope can analyze this light, searching for molecules such as water vapor, carbon dioxide, methane, and oxygen. These molecules could reveal not only the planet's climate, but potentially signs of biological activity. Scientists call these potential indicators biosignatures, and while none have been confirmed yet, the ability to search for them marks a turning point in human exploration. For the first time, we are not only discovering planets, but beginning to study them as worlds with environments of their own. Exoplanets also teach us about our own solar system. By seeing how different planetary systems can be, we learn that our arrangement of planets is only one possibility among countless others. Some systems have giant planets extremely close to their stars, something once thought impossible. Others have tightly packed chains of planets orbiting in resonant patterns, where their gravitational interactions keep them in stable rhythmic motion. These discoveries challenge old theories and force scientists to rethink how planets form and migrate over time. Many planets may not form where we see them today. Giant planets can drift inward, disrupting smaller worlds, while rocky planets can be scattered outward. The architecture of a solar system is shaped by chaos as well as order. In recent years, astronomers have found Earth-sized planets in nearby systems, such as Proxima Centauri b, orbiting the closest star to our Sun. Others, like the TRAPPIST-1 system, contain multiple rocky planets packed into an incredibly tight region, offering a laboratory for studying habitability. Each discovery fuels imagination because these worlds are not abstract points of data. They are real planets with skies, surfaces, and histories, even if we cannot yet visit them. The coming decades will bring even greater discoveries. Future telescopes may be able to directly image Earth-like planets, separating their faint light from the glare of their stars. Scientists may one day map the surfaces of distant worlds, detect oceans, clouds, storms, or even seasonal changes. Missions are being designed to search specifically for Earth analogs, planets that resemble our own in size and temperature. And with every improvement in technology, the universe becomes more populated, more complex, more alive with possibility. Exoplanets remind us that the cosmos is not empty space punctuated by a few stars. It is a galaxy of worlds, most of them unseen, each one a different outcome of planetary evolution. Some may be barren, frozen rocks. Others may be violent infernos. Some may host deep oceans under thick ice. And perhaps, somewhere, one may be home to life looking back into the same universe. The discovery of exoplanets has turned the night sky into something profoundly different. The stars are no longer just distant suns. They are potential solar systems, each with its own family of worlds. And as we continue to search, we are not only learning about planets far away, we are learning about the possibility of life, the uniqueness of Earth, and the vastness of what remains unknown. In the darkness between the stars, countless worlds are waiting, silent and unseen, and the story of exoplanets is only just beginning.